Okay.
Okay, with those obstacles cleared, this morning you first heard science, then applications. You can make food, you can make houses, really cool stuff. The next question is, if you can print food and print houses, it has very interesting implications for businesses of who buys and sells. And I had paused a question this morning until this session. This session is now all about, if you can ship data and make things, what does that mean for the future of business? So we've got a group of great people to talk about that. First is going to be Derek about Pinocchio. So go ahead, Derek.
Okay, no worries. So hi there, everybody. My name's Derek Ellie. I'm one of the founders of Pinocchio. And you're just putting the slide show up, are you, Neil? And I'm going to talk to you about what we call the future of product. Our company was founded back in 2007, and by myself and a chap by the name of David Tenhav. So we kicked off at the end of 2007, and when we first started, the question that was on. So, Neil, if you want to jump to the second screen.
Sure, we're just getting there.
No worries. Okay, cool stuff. So the chap in that photograph you can see on the magazine is David Tenhav. That's my business partner. The two of us started, as I say, back in... we actually sat down in 2006, had a couple of ideas. And Dave's background is in technology. He's an engineer. My background is in marketing and business. We came together with the idea of changing the world around the future of product. And we sat down and asked a couple of questions. Next slide, please. That's okay. Yeah, cool. So these are the questions that we asked. What happens when the cost of oil skyrockets? What happens when the cost of carbon is actually priced into goods? And what happens when consumers expect individualization? Well, the answer to those three questions is very expensive product. So what we did is we set about building a solution to solve those problems for the future of products. Next slide, please. The other way. Cool. And so the solution that came out of those questions was this idea of distributed manufacturing. Everyone in the room obviously knows what that's about. So we set about building the system, and the idea was to be able to deliver product at the last moment possible, as close to the point of consumption as you could. In other words, desktop manufacturing or in-home manufacturing. And today we've started by connecting a number of fab labs around the world, if you like. Not the fab labs as in your brand, but in general. Next slide, please. And so the way that we kind of saw Pinocchio back in 2007 was this continuation of digitising information, and we set about creating a place where you could create and distribute what we call digital product kits, and I'll go into the definition of that a little bit later. Next slide. Thanks, Sherry. So that was kind of the genesis of Pinocchio. Of course, there was a whole lot of work that went into formulating who we were and how it was all going to work. And over the last 4 years, we've grown the organisation. We've got offices in San Francisco and Wellington, so I'm calling from Wellington now. We've got 14 fabbers around the world, in the United States and Europe and New Zealand, obviously. There's 50,000 personal factory accounts have been set up at our site. I'll talk about that in a moment. Over 100,000 goods have been custom made. So the thing that we said about building, next slide, thanks, is this thing that we called personal factory. And the idea with personal factory is that you can turn your ideas into custom goods. The next slide here that shows is a layout of how personal factory works. If you like. Yeah. Cool. And so what you're seeing there is result of 4 years of work so far. We've been a long way. We've done a whole lot of stuff. We've put together a whole lot of things, and this is where we're up to. So if I just take it from the left side, you can see the custom goods. Your ideas go in at the left-hand side. They come via something that we call an app gateway. We set that up about 2 or 3 months ago. The idea there is to capture a whole lot of apps, connected it to a making platform, a personal factory making platform. And the purpose of those apps, of course, is to output design files. They then go into that middle section. Those digital product bits can then, they get priced, and they got all the information you need to then set it to the right-hand side of that diagram and out to a making device. That making device then is able to make those things. Next slide, thanks. Oh, yeah, got it. And so an example of an app that is connected and in the process of being more deeply connected to Personal Factory is Autodesk's 123D. And so what that does, of course, is it's used to create product designs and then export them into the Personal Factory making platform. So that slide you're on now, that's the crux of the making platform. The ideas, you generate ideas, you import the raw digital designs from a design app like 123D. Our system then ensures design files, because there's a difference between raw designs and makeable designs. And then we create digital products out of them. So we enable the addition of materials and method being the making device, assembly instructions that we provide through the system. Next slide, please. Once that product kit is created, that means that the product is ready to be made and can be sent out to a making device. So, for example, we have 3D systems connected to Personal Factory, and what they do is the receipt and make a prepaid job. So if I brought that down, next slide, thanks, into some little detail about FabLabs and the idea that FabLab connected to Personal Factory to receive prepaid making jobs. Slide, thanks. Cool. You can see that there's a pile of things that this system does. It's essentially a job management system, but what it enables any manufacturer to do is receive, as I said, system pre-defined. And the core features there are listed on the benefit. So what happens if people upload their designs? There's also just checking inside of the system. What that means is you don't have to receive emails with broken designs and spend a lot of time consulting over designs. We have a very computing way of looking at these things, and so far as hold kind of true to the maximum crack out. So we certainly put the back on the designer or the creator to in designs. If they get the design wrong, our system completely gives on-screen messages of how to fix those designs. Obviously, what it also does is give instant online pricing. That means there's no manual quoting needed, which is a massive time suck. And then, of course, they prepay online, so everything's prepaid before you do any work. And that means there's no data signature, there's no cheating people. Yes?
There are network issues somewhere between here and you, so the audio is very hard to understand.
Okay.
Given the limited connection, you need to speak slowly with a lot of spacing.
Now I've lost you.
Do you hear us, Derek?
Can you hear me? Sherry, if you wave, that means you can hear me.
Can you hear us?
Okay, so I can't hear anybody there. So I heard you say speak more slowly.
Yes.
Okay, so thanks, Sherry. There's a materials catalogue attached to the system, and what that means is you're able to manage all your materials into the sales zone on the website, and it means that you're not getting any waste in terms of people bringing in odd things or you having to order things that people don't want, and so that's all. We've got a process of being able to make sure of no waste. Next slide, thanks, Sherry. So the other parts of the system, as I said, I kind of called it a job management system. So there's a screen that you manage all your jobs from, and a process that when you go through the process of making something, you just click where you're up to in that process, and then you can take a job through from start to finish, and it's tracked online. And then in terms of that CRM system, every time you click a button, the customers are notified of where the job is up to. So what that means is you have less people emailing you, calling you, asking where things are up to, because you're proactively communicating with them. And there's a global shipping system attached to the software as well. So that's the personal factory software from a manufacturer's point of view. It's the system we've been using from day dot. Today we use that to manage laser cutting, 3D printing and CNC routing on a shop bot. And as I say, there are 14 fabricators around the world that are connected using that system. So next screen, please. So an example of someone that is using the system is a company called Formulor. So they're currently in Berlin, Germany. They provide a manufacturing service. That's their homepage of the system. If you go to the next screen, thanks. It's in both English and German. And what people can do on that site is get all the information they need about the materials and how the process works, and then they can log in and make something. And so if you go to the next screen, thanks. And so on the inside of the system, once that's it. On the inside of the system, once someone has logged in, that's what they see. And that this is the inside of a personal factory account, and it's the page where you click that blue button, and at that stage you're prompted to upload your design file. The system currently, as I say before, deals with both 2D and 3D, and gives instant pricing for those. And then once you go through the system, it's literally you upload the design, you select materials, you get an instant price, and then enter your credit card details and shipping details and push go. And at that moment, the job is prepaid and confirmed, and then falls into that job management system for the fabricator to handle. and then the fabricator jumps into action after that with a job on the job queue. So that's my 15 minutes, I think. So I can't hear you, Neil. I can see you.
Boy, thank you. And with that, any questions for Derek about Pinocchio as a platform? Can you talk, Derek, now a little bit about
Neil?
Yep.
Why don't you ask him whether he wants Fab 8 in New Zealand?
So, Derek, the question is, should Fab 8 be in New Zealand?
Absolutely.
Okay, maybe for time, we can pause there, but I'll link this online and you can reach Derek through Pinocchio. So, thank you for bearing with the hiccups. Thank you for that, Derek.
Okay, thank you.
We're going to go over to the Polycom. And Mark, can you hear us?
Can you hear me?
Yes, we can. So I'm delighted to have Mark, who's now going to talk. Well, you can introduce yourself and talk about making and sharing making. So go ahead, Mark.
Absolutely. Thank you, Neil. So my name is Mark DeVink. I'm the Director of Product Development for the Maker Shed and Make Magazine. And I'm going to touch base a little bit on our background as far as manufacturing and what I do and what the Maker Shed does and some of the background of Make. And then hopefully that will lead us down a bit of a windy trail to digital fabrication and what I think is going to be the future of a lot of our projects and kits that we're developing. So Maker Shed originally spawned from Make Magazine and Maker Faire. I think it was the original Maker Faire where we had just a little card table set up to sell a few different products. And the purpose of the Maker Shed was we had a lot of readers who were interested in being able to purchase these kits. And, many years ago, Heath kit was popular and kit making was popular, but about 5-6 years ago, it wasn't so popular. So the Maker Shed started carrying kits from, the typical makers in the DIY scene, like the Mitch Altmans and the Adafruits and the Evil Mad Scientists. And as that grew, we started to find new makers and help them get their product to market. A nice little side story is, I think it was in 2007, I met Dale Wheat, who was a maker in Austin. He was at Maker Faire and he was exhibiting one of his robots, and he had this little electronic Cylon running. Neil, I'm not sure, am I on the, do you have video of that? And, his idea was, well...
Mark, it's coming through just fine. Carry on.
Okay. His thought was, why would anybody want to buy this little kit? Why would they want to buy these electronics? And one of the great things about my job is I'm there to explain to makers that people do want to buy these little kits. People do want to make things. The maker movement is growing. People are really interested in learning electronics and working with their hands again. So if we flash forward a little bit, about a year or two later, we started designing our own kits and getting into our own manufacturing. And we basically have 3 different kinds of kits that we manufacture right now. The first one would be obviously like our original kits. The first kit that I ever designed was one of these little Learn to Solder pins. And we do these at the Learn to Solder and Maker Faire. And last year we taught 10,000 people how to solder these together, which is just an amazing number. I think it's far beyond what any of us anticipated. And it really showed that the maker movement is alive. The people are actually there. It's not just people on the internet. They come together and they want to learn a new skill. Another product that I've done was things like, Maker Shields, which is an Arduino shield that we developed because, again, we tapped into our community and they wanted something that had more features than some of the current kits that were out there. And so we developed that. A big push for our own kits, or where Make comes in O'Reilly's, is when we talk about things like publishing. Everyone knows O'Reilly's is a huge technical publishing company, and they create these great books like Make Electronics and Getting Started with Arduino. And what we've been able to do now is create kits based on these publications. So we're tapping into that educational market, and we're finding that people are really happy to be able to get one kit in one location, have incredible content and editorial along with all the parts needed to expand their skill set. The next category of kits that we're kind of working on, and this starts to go a little bit towards digital fabrication, are kits that support, Make Magazine. An example would be something like our Pendulum kit, which is a fun little game that, and I hope I say this right, Ken Delahousse developed, and we actually manufactured for him. And we've been trying to launch a few different kits with the magazines, and that's been working out really well, and we're excited with the direction that's moving. And then the third kind of kit that I'd like to talk about we're finding more and more with the increased interest in making in this DIY community, that there's a lot of makers out there that have these great ideas for kits, and they don't want to manufacture them. They have no interest in manufacturing. So what we're able to do is take their great idea and develop it for them. And what we've been exploring now is the difference between a kit that somebody would like us just to manufacture for them, or a kit that's open source or closed source, and how do all those work, and how that's going to work in the community. That relates to even digital manufacturing. As if I put a design out there, is there credit to the author? Is there a royalty payment? What we've been exploring is kind of like the book model, and we're hoping to do a royalty payment, or we already do a royalty payment to these makers, and we handle all the manufacturing. One example that leads me a little bit into supporting the magazine and a little bit with digital manufacturing is, hopefully you can all see this, is we did a little robot in the latest issue of Make called Spazzy, and he was inspired by another robot that was developed to help kids in communication. And what's interesting is we're starting to see projects in Make Magazine and kits that we're developing that have components that are from 3D printers, or have laser cut wood or laser cut acrylic. And we saw that maybe a year or two ago, but it wasn't as easy for people to go to places to get their laser cut wood or plastics. And now with the emergence of Pinocchio, and people have maker bots in their homes, or the hacker spaces that are popping up all over the country, it's becoming much more obvious to us that projects that have 3D printed parts are important to us, and we're seeing a lot more come through. So it's an exciting time. It's an exciting time for us to see these projects. I think we have Alicia and Aya coming up and can talk about that open source, but that's really the challenge that we're facing now, is with all these digital fabrications, how do we supply these kits to our readers and our customers? Do we manufacture the 3D parts for them, or do people have access to these 3D printers, and do people have access to laser cutters? You can get a laser cutter now for under $2,000. So it's a really exciting time for the future of digital fabrication and kits, and we're just figuring it out now, I think, along with everybody else.
Okay. So to transition to questions, thank you, Mark. Let me start with the question of if people want to sell stuff through you, how do they do it? How do they get started?
Well, you can go to the Makershed website and contact us. You can certainly email me. I think our information's all readily available. As far as selling in the Makershed, there's so many different models. It's whether you have a kit ready or you just have a kit idea and would like us to manufacture it for you. Basically, we need, we're always looking for great kits and great ideas, and we would love to work with anyone to help them develop it. And what's unique to Makershed and Make is that not only can we manufacture the kit, but we have all the media behind it. We can do a book based on it or an article in Make, and we can put it up on our website that gets millions of views a month. And, we're always looking for great kits. And please contact me, email me.
So questions for Mark about Maker Faire, Make Magazine, Makershed, buying and selling things you make. And I'll repeat the question for you, Mark.
Okay.
I would like to know more about the revenue share model between Maker and
the question is about revenue sharing. Can you trace through examples of what money goes to who through the life cycle of inventor, platform, producer, seller?
Okay, sure. So I guess basically there's two models. And the most simplistic way to explain it would be typically if a maker is producing a kit, let's just say it costs them $10. That person really should wholesale it to us for about $20. And then we would typically retail it for about $30 to $40. A common beginner mistake with kit makers would be that, and this happens every day, believe it or not, someone will say, well, this cost me $10 to make. I'll sell it to you for $11, or I'll sell it to you for $10. And we're not interested in that, mainly because I want the maker to make money so that you can continue to make more cool kits. And that's very important to us. The other side of that would be, say you just have an idea for a kit. What we would typically do is be able to offer you a royalty. And we would do a royalty based on sales, based on the retail sales. The royalty is loosely based on a book model, but it can be anywhere from 10% and up, depending on how complicated it is, how much it would cost. You have to remember that would be kind of, you just have this great idea, you say, hey, this is my idea, would you like to make it? And we say, sure, and you collect a check, and you don't have to do too much. It's important to us to pay a royalty, because we think it's really important for the maker to have motivation to support it, and it's also important to give that recognition and have, hopefully, you develop a kit and you make a little bit of money and you can develop another kit for us. So it's really important to us that the maker makes money.
Any other questions? What about the two sides of, do you get many submissions that, I'm muted. What about the two sides? Do you get many submissions that are terrible and you have to say bad idea? And do you get many cases where people have stuff that should be submitted, but they say, I think it's a bad idea, and they're wrong? So both sides of misjudging your own work.
More commonly than not, I have people that will contact me and say, I have this great idea. It's amazing. And again, more often than not, I agree with them. The problem is, it usually already exists, and we might already be selling it. That's very common. It's amazing. I just had a conversation earlier today with someone who had a kit, and we have the exact same one in the Makershed as we speak. As far as a bad kit, there are some, but I can't say that they're necessarily bad. They might not be good from a commerce standpoint. There might not be a good way to monetize the idea. But truly bad kits or bad ideas, I would have to say that it's very, very minimal. What's more common is I see great ideas that are poorly executed. where it's a maker who has just this amazing kit, and you go, okay, wow, that is great. It could sell for about $20, and you say, could you send me more information? And you find out that the way they're doing it costs, $50, and the execution just isn't right from an e-commerce standpoint. So, one of the great things about my job is day in and day out, I get to help makers, whether we sell their kits or not. I help people develop their kits and do it in a way where they can be successful.
Okay, that's great. So with that, let's thank Zach. And in transitioning from him, sorry, I said Zach, I meant Mark, of course. Let me note that Very Serious offer that they have a platform to sell kits, to produce documentations, articles, story, that whole package, and they're always looking for new projects. So this isn't a story about somebody else. This really is an opportunity to sell the things you're inventing. So with that, thank you. And then in person, we'll hand off to Zach now for Inventables. Same, don't switch the beamer, same cable. Don't switch it, it should be the same.
Buenas tardes. So thank you for inviting me to come to Lima. My name is Zach Kaplan. I'm the founder and CEO of Inventables, and we are the Innovators Hardware Store. So Inventables was really started in this picture. I was about 4 years old, and that's my father and my little brother Jordan. And when I was a young kid, my parents used to buy us all sorts of construction toys, whether they were Legos or, in this case, Tinker Toys. And I would spend hours and hours and hours building things like buildings and cars, imagining that I was an engineer. And I developed a bit of a frustration and a love for Legos because, on the one hand, these bricks would help me build a skyscraper like the Sears Tower, but on the other hand, when I would show my mom or my friends, they would be like, nice job, that looks like Legos. And so I was a bit frustrated because I wanted the designs and the products that I was making as a child to look real like the products that we saw in the store. And so when I graduated from college, I started Inventables to find the Legos that real engineers use and real designers use in big companies. And so what happened is, for many years, Inventables was started in 2002, and we would do research for the largest manufacturers in the world, companies like Coca-Cola and Black & Decker and Procter & Gamble, on what are these new materials that they can use in their products. And what started happening over time is the machines that were used to manufacture all the products started becoming less expensive. And you've been hearing about this all morning. Some of the most important ones, over the last 20 years, if you look at what the least expensive laser cutter or mill was in 1991, they were in the range of about $25,000. And the most expensive ones were over $250,000, sometimes even over $1 million. And so if you look this year at some of the least expensive machines, the software to do your designs is now free. The entry-level packages are all free. Jonathan Ward, who's here this week, has developed a CNC mill where the parts cost about $500, and you can make it yourself. The MakerBot guys have a CNC printer that's about $1,000. And there's laser cutters out there now that you can order for about $2,000. And so this whole community of machines and software and parts is now being brought together in things like the Fab Lab. And I thank you, Neil, because just the machines alone aren't enough, right? It's more about the ideas and how you can put them together into personal factories and digital fabrication and local fabrication. And this concept of the Fab Lab is really igniting a revolution, I think, globally, that is going to bring a lot of countries from maybe a poverty-type state into wealth. Because locally, you're going to have factories on every corner, and sometimes factories in every house where you can make. So at Inventables, we believe that when the tools become easy to access, humans are going to create. And all morning we've seen this creation. And so what we did 2 years ago was moved away from helping the biggest companies in the world and taking all of that knowledge and expertise and materials and helping the littlest companies in the world, or just individuals. And so we launched this website. It's an online hardware store for desktop fabricators. And so in addition to some of the traditional materials like acrylics and woods and other plastics, we have this massive catalog of more unique and interesting materials that maybe aren't always top of mind. So for example, hand moldable plastic. It's plastic that I brought here today, and you heat it up to 140 degrees, and then you can make it into any shape you like. Shape memory polymers.
Okay.
Polymers that you can shape into a specific size, heat it, and it'll change back to the original shape. Powerless illuminating tubing, so tubes that charge up with the light, and then when you bring them into the dark, glow like a light without electricity. And then also things like acrylic sheets in the shapes and sizes that you need for a laser cutter. So in everything we do at Inventables, we're trying to make this process of product development and procuring materials inspiring, but also very easy to do. And so even though we have everything on the web, we've noticed that sometimes it's hard to tell colors when you're looking at a screen, or different screens have different colors. So we're working on things like sample books that you can keep in your lab, and we're going to give one for free to every fab lab that came today, so they can have it on hand and really see what the different colors are like in different lights and different angles. And I also brought some hand moldable plastic, and so whoever asks the first question when Neil asks will get a free bag of hand moldable plastic. So get your questions ready. So the hand moldable plastic was recently bought by a gentleman in Canada who had just had a baby, and he bought this baby gate. But when he took it home from the store, it was missing a part that lets you connect it to the wall. So he heated up some hand moldable plastic and he made the part himself. It was easier for him than calling customer service and arguing with them about where's the connector piece. And so it's a funny concept, but it's happening. And so to take it a step further, we're starting to see now what I call student factories. So these two gentlemen, Anthony Serra and Russ Akimian, are from Chicago. They each went to a university in Chicago, and they're engineers. They love video games, and so they played video games all throughout college. And they started playing them on the iPad and the iPhone. And one of the frustrations that they had was, on a game like this, there's no joystick, there's no button to press when you're trying to shoot the aliens. So they got to work and started sketching out how could you have a button work with the iPad. They went on our website and they ordered some conductive rubber for a few dollars and some suction cup tape. And they created this, which is a button that affixes onto your iPad. You can take it off, and it doesn't leave any marks or scratches. The suction cup tape suctions it down to the screen. They went on Kickstarter, and they raised just over $11,000 for the project, and then went into production and gave some to all of their customers. So this is part of what I call the Etsy economy, but these two guys, they didn't have funding. All they had was a need that they saw, an idea, and a lot of energy. They were doing this on nights and weekends. But the Etsy economy is making a whole new class of folks, the folks that Chris Anderson was talking about, the 10,000 or 1,000 to 10,000 unit production runs possible, because you can now sell your goods on Etsy or through Kickstarter. And so we're starting to see people go to a fab lab and use the laser cutters to cut out their parts and then sell them. So for example, there's a woman who goes to the fab lab in Rhode Island, AS220. Hello. And she ordered some mirror acrylic, and she makes jewelry. And there's all different words that she sells. She sells the necklaces for about $12. There's another woman in Nevada who makes these crane games out of red acrylic. And so when I saw these two, I thought, they're very cute, they're very niche-y. There's obviously a demographic of folks that like it. And then I saw this one. This woman makes bamboo clocks. And it really blew me away, and it really made me take a step back and think about, this woman, she's a designer, and she's an artist. And I mean, that clock is beautiful. And if you would go into any of the high-end stores in America to look for a nice clock, you would expect to see something like this. And she's also done multi-layer ones, where she's taken opaque acrylic and bamboo in the back. And so it's now starting to come to the point where the products made by folks in the Fab Lab and makers are nicer, or maybe sometimes even better than stuff that you can find at Walmart or Target. And so to further this, Inventables is very interested in helping to democratize access to materials. And there's lots of different ways you can do it, but we're thinking about, if you were to start a hardware store in 2011, how would you do it? Where is it going? And so what we're launching at this conference is what we call the online workspace. And this is a free tool that you as a maker or an inventor or a product designer can add yourself. So this is John Linton's. To the site, and then you can also add projects that you're working on as you're working on them. And the idea is to showcase your projects, and also get help. And so you can see on the left side, there's a conversation where different people are helping him with his design, answering questions. And if you're on the site, you can help other people. Everybody from our company hangs out on the site, so we'll give any expertise we have. You might think about it as the old man that used to be at the hardware store where you go and ask all the questions. Now we've put him online for everybody else to share. And so if people come to the website and they just like your idea, they can like it, and it will go to their Facebook feed. So the homepage lets you browse through all sorts of other people's projects, so you can explore them, you can comment on them, you can like them. But as we move into the future, we think of this as just a starting point, and we intentionally didn't finish the workspace because it's through feedback from the community that we want to evolve it to how it should be. And so I'll give you one more example. Oops. This is Ned Molka. He's an industrial design student. He just graduated from the University of Illinois. He's very interested in cameras. He studied cameras, and he's an amateur photographer his whole life. In school, he designed a new kind of camera. This is his rendering. These were all the parts that he had that went into the camera. And so we're going to be adding features where you can tag the different materials that he used, or he can tag them, or you can tag them. So as people are shopping, they can see what other people have done, or what materials our camera's made out of. Then he went on, he actually made prototype and his final piece, so he actually made the camera. So as we move forward, really what we're trying to do is create an R&D lab on every desktop. And I invite you to join the revolution. Thanks.
So we've caught up for time, so we do have time for questions. Let me start with the question of, if you take Pinoco's, Shapeways, Inventables, Maker Shed, help people understand the taxonomy of how do they all relate? How do you relate to them?
Sure. So Inventables, you might think about us like a hardware store, or the supply chain, so to speak, where we're selling materials in quantities of one. So if you only wanted to make one, that's fine. If you wanted to make two, that's fine. Maker Shed, the way I think about it, is more of an educational space where you can order a kit and learn how the designing principles. And Pinoco or Shapeways, I think about them as, like Derek said, a personal factory where they're going to manufacture. You submit your design, they're going to manufacture it, in some case help you sell it to your customer. So if you were to design something on Pinoco, you wouldn't order from Inventables, but if you had your own laser cutter or ShopBot, then you would order from Inventables and we would send you the materials.
Questions?
What are your top 3 best-selling items?
Well, the question was, what are the top 3 best-selling items? So you're about to get one of them.
Excellent.
Nice. Congratulations. Yes. So you just won A new car. No, you just want hand moldable plastic, and so you can heat that up to about 140 degrees, and it'll become like clay, and you can shape it into any shape you want. If you want it to be really ambitious, you can go to the Medela or another CNC machine and machine out a mold, and you can pour it in there. You can also mix in pigment and change the color. So that's one of our best sellers. Acrylic, we have about 42 different colors of acrylic. We're about to go up to about 60 different colors that include glossy, mirrors, mattes. That's definitely number 2. And then number 3, I believe, is actually the glow-in-the-dark tubes, where people use them as an alternative light source that doesn't need power.
Amy?
So one of the
And I'll repeat the question, so don't worry about the microphones just for time. Go ahead, Amy.
one of the best things about a hardware store is you can walk in and kind of walk around and fit your object together while you're trying to make it. Is there a comment about that? Is there
Right. So
an example?
the question is, I have fond memories from my childhood of going into a hardware store where they used to let you touch things, where there'd be aisles and aisles of just, nuts and bolts and lots of nails you could fondle and figure out, and just enjoy holding the nails. And so talk about browsing.
So we're doing our best to take really rich pictures of all the different things, but we understand that pictures only go so far. And so we're working on a collection of sample books, like the acrylic book I just showed, for each of the categories, a wood book, an acrylic book, a fastener book, that you'll be able to have in your lab to be able to touch everything. But aside from that, if you're in Chicago, you can swing by our office and we can give you access to the inventory. Or you can just order one just to test something out.
There was another question in that direction.
Yeah, I wonder if it's made for the American market or worldwide. Does it make sense to ship acrylic from America to Spain?
So the question is about domestic versus global.
So roughly 40% of our customers are international. We charge $34 to ship anywhere in the world right now. And it turns out with acrylic, for example, it's a lot. The dollar is so cheap compared to the euro, and there's an acrylic shortage in Europe. So we're getting a lot of orders from Europe because America is the new low-cost country, and we're selling it for significantly cheaper than Belgium or Germany.
It helps to come from one of these developing countries with an embattled currency. Anybody else?
So if we had access to vast amounts of scrap material, could we sell that to Inventables?
So the question is, more generally the question is, the starting question is, can we give you our scrap? And the question beyond that is, if we have cool stuff, how do we sort of push cool stuff through you?
Sure. So we're definitely interested in talking about that. So you can email. I get every email that goes to help@inventables.com goes to me. So just send us an email, whether it's an idea that you have for a material you want to sell or some scrap.
So if there are no more questions, I would end this stretch with the challenge of...
So we are launching the workspace here today. So anyone, it's only open to the Fab Lab right now. So if you do want a free account to go test out, go to inventables.com/workspace. And after you sign up, I'll activate you when I get to my computer.
Okay. So I'll give you a challenge of putting your presentation on this. And the challenge for everybody else is what none of these platforms have spoken about is the idea that every lab in this room is part of the production facility. And you use it as a distributed production platform because it's not sort of none of the people involved yet understand how to weave it together. So kind of the homework assignment from the session is these are all great starts for buying and selling that's not a store but a platform. How do you make the platform scale to the diversity and the reach of this room? Okay, so with that, I'll then go over here. Aya and Alicia in New York. I'll introduce them.
So my name is Alicia Gibb, and I am the R&D Lab Director at Bug Lab, where we make a handheld Linux platform that you can snap various modules into that have different functionalities to prototype your own device. I'm also a member at NYC Resistor, which is a hackerspace in Brooklyn, and I hack on various things. I did my thesis on the Arduino microcontroller in art, and the reason I got interested in the open hardware movement was because I had a strong interest in the freedom of information from my library and information sciences background. And to me, open source hardware is the freedom of information for atoms and objects. Next, please.
My name is Aya. I'm an interactive artist. I graduated from Media Lab at MIT. I was actually a Neil's student. And it was in Neil's class actually that I got introduced to open hardware because of a class that we were taking called How to Make Almost Anything, where we would just put up our projects and put up the files that we were using, and it kind of got me acquainted with the field. I'm a fellow at Creative Commons, where I do research in open hardware, and I'm the founder of Littlebit, which is a library of pre-assembled circuit boards that snap together with magnets to enable artists, designers, kids to create with electronics. Next, please.
So what is open source hardware? Well, open source software has been one of the biggest successes in innovation and business in the 20th and 21st centuries. So it's inspired by open source software. Engineers, developers, and hackers from around the world have begun to make deliberate attempts at sharing hardware and standing on each other's shoulders to make things bigger and better. Next, please.
So a key example when talking about open hardware is Arduino. So we'll be talking about Arduino in more detail in a minute. But basically, to open a hardware project, to open source a hardware project, you need to open the source. And the source, in the case of hardware, is much more complex than it is in the case of software. We're talking about CAD files, we're talking about schematics, bill of materials, board files. There are lots of different components that you need to open as a source in order to share your hardware project. Next, please.
So why is this hard? The main stumbling block of open hardware is that while software is easy to duplicate and can be copied for free of charge, hardware is made up of actual matter, so it's atoms instead of bits. And hardware requires initial investment, it requires materials, tools, expensive distribution, manufacturing, and replication.
Next, please. So we need to share all these different types of files to enable other people to replicate and reproduce our work. Open hardware is also very difficult because we're countering decades of a patent system that's very complicated, very expensive, and very entrenched in our corporation, where innovation is essentially locked into corporations that can afford the patent system. Next.
So why is this important? Next. All the electronics that we touch have become black box. So we have no control over the goods that we consume. Like the fab movement, we want to take creativity from the hands of the big companies and put it into the hands of individuals and innovators. We know this is working because Paolo Antonelli, who is the curator of architecture and design at MoMA, says about open source that it is the basic brick to everything in the art world. The Arduino and the automation of objects are becoming really open to artists and designers themselves, and that's what's the big revolution in open source. Next, please.
So how did all of this start? From my end, I was working on Littlebit. It was my little project, a library of pre-assembled circuits that I wanted to make available. For the library to be useful, it has to be big. And for the library to be big, it has to be open source. And so I was working with John Wilbanks, the VP of Science at Creative Commons, and he was mentoring me on thinking about what are some legal frameworks around creating hardware in an open source fashion. There are no licenses out there that were at the time useful for hardware. On one hand, there are all the licenses of Creative Commons that are governing copyright, so documentation of files as opposed to the hardware itself. And on the other hand, we have the patent system, which is a very expensive and, like I said, very complex system. So there was no real legal framework. So I decided to start to open up this process a little bit and talk with peers about some of the problems that they were having with their projects. And so in March of 2010, I had a workshop called the Opening Hardware Workshop at IBM, where I invited a bunch of companies and Creative Commons was there to talk about some of these issues. We, after thorough discussion and research, we decided that trying to develop a license was actually not going to be an easy or a useful at that point sense. We decided instead to define what open source hardware is. So instead of embarking on through the legal system, we decided to take a community approach and to develop a community-driven definition of the open source hardware. Next, please. This gave birth to the open source hardware definition. Next, please. The process of crafting the definition was very open. Actually, it's one slide back. Sorry. It was very open and collaborative. Sorry, Neil, we flipped the slides with mistake. Can you go to the next one? Sorry, yeah. Thanks. So the definition was put on a wiki and discussed in mailing lists and forums and published every step of the way. So everyone helped us get the word out, and because of that, yes.
Can you slow down a little bit? It's hard for the translator. You need to go a little
slower.
Sorry. More space between your words. Thank you.
Okay. So we were saying the process was very collaborative, and each step along the way was published on blogs in the internet, and everyone helped us get the word out because everyone owned part of it, and they felt that they all had a piece in it. So we put the definition up on a wiki. Everybody was able to edit it. We had different people insert different clauses and then iterate on those clauses, and at every step of the way, we would publish it, and people would give feedback on the forum, on the mailing list, and as comments. So can you go back to the one before, please, Neil? So this is version 1.0 of the open source hardware definition. It starts with a statement of principles that is basically an overview of what open source hardware is, according to how we came up with it. And there are also 12 clauses that essentially...
Okay, we've got Aya and Alicia back to join us to finish their remarks and have a little discussion, and then we continue on with the final session. So Aya and Alicia, please proceed.
Oh no, there's a loop.
Go ahead, we're ready for you.
Okay, thanks. So basically, there's a lot of success stories in the open hardware space right now, and we needed a way to let everybody kind of have a stamp of a mark on their stuff designate open source hardware. So we started by having a logo competition and created a logo out of that competition. There were 129 votes, which is significant because submissions, I should say. There was 9,000 votes, which is significant because there's only, less than 50 open hardware companies out there. So clearly, this movement is bigger than just the people making it. We have more information on the Open Hardware Summit website. You can see the definition, you can see the logo competition, you can also see a list of what are some of the open source hardware companies, ranging from little projects to global scale companies that are trying to resolve large scale pollution and earthquake damages problems. And we're having the summit again this year, September 15th in New York. So please join us if you can. If not in person, then you can watch us on Ustream, or you can join the forum or the mailing list. And we'll put documentation up afterwards. So thank you. Sorry about the tech trouble.
Great on open hardware. Any questions about that space?
What was the beginning of that sentence?
I'm going to repeat the questions to you. Hold on.
What are the implications for the intellectual property industry?
So, the question is, there's an IP industry. What are the implications for the IP industry of open hardware?
So, the IP industry is pretty set in its ways. Companies that and people that want to apply for patents are continuing to apply for patents, and we think it's not going to stop. But we're seeing more and more people start to open themselves up to the idea of having some kind of license that protects them against the big guys, but not against the small people. So these are people that are adopting, for example, Creative Commons non-commercial licenses, and we think they're just one step away from adopting the commercial licenses, which will allow other people to commercialize their projects. On the other hand, there's OHANDA, which is called an Open Hardware and Design Alliance group in Europe that's developed a trademark approach where you can join OHANDA and become certified as an OHANDA certified project, meaning you've upholded their 4 freedoms and you get a stamp for it. So there's several different outlets for that, and we think the open hardware license from CERN will also help in starting to combat the patent system. But it's a big and old system, so, it's a big battle.
Any other questions? Let me ask one. Greatest hits of open source software have been things like the Linux kernel or the Mozilla browser. Free associate on what success is going to look like. What are the home runs of open hardware?
Well, I think, for one thing, I think we've already had home run, which is the Arduino microcontroller. So, for example, they're up against companies like Texas Instruments. And when Texas Instruments starts making a derivative of the Arduino, you know that it's like kind of something that that people are paying attention to, and that obviously these large companies who've been around for years and years and years are actually a little afraid of. So that's been a home run. And they recently got adopted by Google as the platform as their development platform for the Android. So we're probably going to see a lot of projects coming up that are going to be using Arduino as a platform and derivatives and making it a home run on a large scale.
Okay, that's great.
I think the other home run is just like all the materials and components that are able and accessible for people to buy now. You don't have to be a massive company to get a couple capacitors anymore.
So if you're interested, the Open
Summit is a great
So with that, well, thank you.
thank you.
Thank you.